Gentlemen, a big hand for our moderator, Suchitra, for leading the conversation. I hope we have more and more of these conversations. I know it will shape our future together. Thank you so much. Dear friends, we have 3 more presentations to go before lunch. Please stay with me. I'm going to introduce our next topic at hand, which is the future of humanoids, innovations, and impacts. Personally, I do not mind having a humanoid helping me out at home with chores. So we're going to dive into the thrilling world of humanoid robotics, where AI meets the biomechanics to reshape industries and everyday life. Ladies and gentlemen, we're going to bring on stage real soon our next speaker. This is co-organized by A-Star, ARTC, brought to you by Ross I Consortium Asia Pacific, supported by EDV, NRP, and SGI. Ladies and gentlemen, from Schaeffler Singapore Private Limited, please put your hands together to welcome Prof. Han Boon Xiu. Welcome, Prof. Han.
Hi. Okay, good. Good afternoon, ladies and gentlemen. So my name is Boon. Just really a quick introduction of myself. Currently, I'm working in Schaeffler. So Schaeffler is basically a German-based company, and basically we are very much into the automotive industries and industrial. A bit of myself. So currently, I'm basically the heading of all the technologies activities for humanoids components strategy, and is actually I'm taking care of Asia Pacific and China. And also, I'm having a directorships in Nanyang Technological University. So basically, I have a lab, basically looking into very much into robotics research. So when you talk about the humanoid topics, for me, it's very, very familiar because I started my passions. To be honest, it's exactly 20 years ago. Back in 2005, this is where I'm still in A-Stars. I already started the humanoids activities. As you can see, all the way from the extreme left, I started the robotic, so-called humanoids doing the Chinese robotic lion dance. All the way, I participate, let's say, to the DARPA challenge But in 2017, I basically stopped. Somehow, I don't really believe in humanoids. Just because of the AI. So in 2017, where deep learning started rising, but I still think that there's basically a missing piece when it comes to humanoid. But eventually, recently, about 3-4 years ago, that's where the large language models comes in, the generative AIs. That's where I believe, because if you really want a humanoid or basically a robotics to perform a task, they first have to have a common sense. So that means that this is how humans behave, is that when you have instinct, when you have common sense, that's where you are able to do things autonomously. So when this comes, I dive back into humanoids activities again. And the second problem is always about the hardwares. So the hardwares is always very challenging. And that's why now I'm back into these activities where how can I actually have the hybrids, or basically combining the best hardware and the best software, so that I'm able to achieve back into the humanoids, into the real world to perform applications again. So about Schaeffler, because when I talk about hardware, it's about Schaeffler, because we are basically a motion company. This is where I start to believe that yes, we are able to achieve types of very good humanoid, because when it comes to Schaefflers, we have 8 different types of motions. So for us, we basically are able to design a very basic bearings, all the way to the top, if you can see, is the gearboxes, the actuators, and even up to the battery stacks. So basically, we are very strong in this. And the second thing is, not only you need to have a good products, but you need to have a good processing technologies for low cost. So in 2005, I remember that I bought my first humanoid. The cost of the humanoid is about $500,000 to $1 million. But can you imagine that currently the sales of a robot is about 40,000? So I reckon that basically the technologies and then basically the scaling of the process of the humanoids are very important. And on top of the AI, that makes a good success. And this is where for Schaeffler, what we are doing right now, because we are a supplier. We supply the components. We are a user also. Later, I'm going to explain how do we actually use humanoids, how do we apply humanoid in our productions plant. And then, as I say, is that we support mass productions for humanoid OEMs. So we support them on scaling. And the last part is always maintenance. So how basically, first of all, I think with our products, our humanoids will last very long, but at certain points, how are we able to have the aftermarket services? I think that's where we believe that for us, we basically provide humanoids components, we understand how to use components, and we know how to scale them. So why humanoid? Yeah, so as you can see, these are all the points. Most probably you all are able to see day-to-day market. But maybe what I believe is that the sales of humanoid in 2030 or a bit beyond 2030 is that the sales number of humanoids will be lower than a handphone, but more than a car. So that means that we are able to basically purchase humanoid at a very low cost that put in our house. That's where my perspective is that the sales of a humanoid will be more than a car, because most probably you need about 2 robots in your house to perform certain type of task. So why humanoid now? As you can see, is that we basically have a low-cost system solutions. We have advanced mechatronics, the booming of AI. So as I say, is that where the robots are able to do reasoning, you are able to train the robots by really teaching them. And then the last one is the real demand of humanoids. Because not only in terms of manufacturing, but because of the aging populations, all this, that we are lacking of skilled workers for support. This is where really I find that eventually the humanoids in 10 years later, or maybe even earlier, will be like the robot vacuum cleaner. So that I strongly believe in this area. So this is where the visions, we say that, okay, in order for us to really sell humanoids components, we have to be a believer of using humanoids. So basically, this is actually our aim of Schaeffler's. We are approaching basically autonomous production solutions. So you can see that basically there is 9 different type of activities that we like to approach for fully autonomous, and 3 of the major activities belongs to humanoid activities. Number 2 is the humanoid robots. We have to apply AI for productions, and of course we need to do the simulations for the humanoids to really understand how do we deploy. So basically the aim is really we want that our issues of productions plan is not that there's, how do I say, we are looking at low-cost workers. It's just that the fact right now is that we are unable to also get enough blue collars productions worker, and that's where we find that humanoid is essential, let's say, for the future of Schaeffler productions plan. So we go step by step when we implement humanoid. This is where Schaeffler basically have a systematics where right now we are at the stage of use cases analysis. We are very serious. We really understand that in these environments, where is the area that we must use humanoid? Because in a productions line is usually very narrow. You can't really use a classical AMR. You really need, let's say, a Lego robots and basically a dual arm. This step by step we are looking at is where we analyze it, we do a pilot run, we consider about the infrastructure. Yeah, how do you connect your humanoids into our productions network? We need to train it, we simulate again, and we correct it, we deploy, and of course, in the end, while we are deploying our humanoids in our production plant, we are able to analyze our own components. So this is where, on the other side, so this morning I saw there's also about standardizations. We also are looking at how do you make sure that your humanoids are safe? How do you standardize? So this is basically like a type of V models that we are looking at also as well. So this is the time right now, as I say, a lot of people are saying it's still far away, but we should look at these are the activities right now to prepare for the next 10 years, because if your humanoid are selling about 20,000 USDs, I think we are quite able to afford to buy the humanoids for our day-to-day usage on that. So this is also an analysis. Maybe this is just an example. Basically, how do we analyze our use case? We basically correlate the value stream activities, the tasks, with the skill sets, as you can see. So for us right now, very much we focus in terms of logistic. We find that it's one of the so-called easier tasks for humanoid. So it's a very repetitive, mundane type of job. We say that we basically are interested to actually deploy humanoid for logistic. But as you can see, is that when it comes to the most complex, which is the process and the assemblies, this is where the humanoids needs to have reasoning, because there's many parts and components. They needs to have a very complex dual arm manipulations. For us, it's always easy to open and close a bottle, but this is one of the most extremely difficult tasks for the humanoid. So that's where we say that we proceed with the logistic and material handling first, and that's where we understand about the humanoids, and concurrently, right now, we are looking at the research of how to do the assemblies. We need to understand how the robots can learn, basically how the robots can correct itself when they actually assemble something wrongly. These are basically type of analysis that we are doing right now. Yeah. Maybe an example, this is just a handling. As you can see, is that we have a production plant that basically we do this type of very repetitive, mundane job. Basically, what we have done right now, at least the first pilot runs, is that we actually use the humanoid and to perform this type of materials handling. So this is something that we are testing right now. We are understanding basically what are the technologies barriers is needed. That's where we are able to collect the data and then basically improve till the robots are robust enough to really perform a real task on that. So as I say, is that while we are trying a lot of pilot runs, that's where we say is that we look into the technologies. We want to look into the technologies and innovations. What are the technologies and the innovations that are missing that we need, let's say, for the humanoid to really be safe, be smart? So this is where we say is that we basically have a team to look at the market trends. We basically also have partners that basically provide technology trends. And also importantly is at least I feel is we need to also understand the timing of the technologies. Yeah, so which technologies are most suitable, let's say, for humanoid deployments, because the timings actually correlates with the cost also. If actually the solutions is too expensive, it doesn't actually make sense for us to implement the humanoid. So these are basically the tasks, and maybe one of the major activities when it comes to innovations right now is for Schaeffler. We have a challenge is that we have many standalone tools. So we have digital plants, connected plants, we have robotic simulations, we have AGVs. The first area of what we want to do is to really collectively collect the technologies and how do we connect to a shared platform, first of all, to perform simulations, and then secondly, from simulations, let's say, to realistic implementations, this is basically the first step that we want to do, yeah, to understand the technologies on that. So if you can see right now, so this is basically a production plant in China. We have already connected machines. So that are the first things that we basically connect our machines all together. So there's basically 60 connected machines. We have 9 robots. The second thing is, if you can see, is that we are able to do this real-time analysis and simulations. And the third thing is that basically we want to really create an omniverse with using maybe part of the NVIDIA solutions. We want to create synthetic data for training, and basically from once you are able to train, regardless the machines or the robots, that's where we know how it behaves, and then we look into the deployments. Maybe this is just a really example. How do we actually use Omniverse? That's mean like with our productions plant. How do we connect the machines and the robots together? How do we analyze the sensors? Let's say that the robot is actually detecting, and this is type of activities that we are doing in terms of analyzing or understanding the technologies on that. So. Another thing is, once we are able to create a very robust simulation, of course, we are interested why into this Omniverse solutions is because we are able to simulate the physical model on that. And reckon that basically this is one of the interesting things. We basically are trained, let's say, it's really in a simulations how to actually put a rubber, let's say, on a tube on that. And we start to actually really learn that it helps. Yeah? After 1 hour of training, after 18 hours of training, you basically see that basically the intelligence of the robots improve. So previously, it takes a lot of times for maybe more than 500 hours for human training of robots. But nowadays, even let's say with this synthetic data training and just a short hour of training, the robot are able to learn in a very fast way on that. So I think this is basically just the step that we do, looking at the pilot use case, analyzing, looking at the safety, and then in the end, we are looking in terms of the training of the robots. This is basically a step-by-step approach that we do. So, and then we also look at advanced innovations in Singapore. So this is where we actually, in NTU, we have a collaborations back in 2017. And this year, we actually have a phase 3 collaborations, really look into advanced AIs and robotics. There's basically 3 areas that we focus on. Basically is the professional service robotics and the new mobility solutions, and of course the smart factory applications or the large language model that we are looking at, the 3 pillars. Yeah. So maybe just to give you a flavor, inside the lab, actually we are really looking at fundamental research or developments all the way from components to the system understanding, and really wants to look at what are, let's say, the unique technologies that we can use to enhance our humanoid business, or even in terms of the applications. These are type of things that we are doing. Maybe just an example, we have a very, how do I say, it's a painful use case. I don't know if I'm able to play the video. Let me try. One of we find that when applying robotics or humanoid, the biggest pain point is the gripper. Yeah, it's not manipulations. And humans are very flexible when it comes to gripper, but what we actually do is that we want to develop universal robots that basically are able to pick up soft materials like the plastic. So we also want the same grippers that's able to pick up more complex stuff like the styrophones or this type of like the vacuum cleaners, all in one, yeah, at a very low cost. So this is basically a research that we use a gecko skin, that's mean the lizard skin, that we are able to pick up the plastic, but we are also using the coffee powder. So if you can see, the green color is a coffee powder where you create a particle jammings where you are able to grip soft and hard materials on that. So very organic, very animal-inspired type of grippers, and it's low cost. Yeah? So basically this type of research and developments that we do in NTU. So what's next? Another beauty about grippers or humans is that we can see with our hand. So what do I mean is that without actually looking at components, you are able to differentiate whether this is orange or apple. This is because back end we have our so-called huge data set, or the large language model that we have. If our skins are able to create an image just like the bottom here, that's where we are able to differentiate, let's say, the products. So this is basically an example. So currently what you do, if you can see the top right, the robots are trying to so-called see with the tactile skins of the materials. And they are able to differentiate which one is the most soft to the hard. So by using generative AI, we say that please try to assemble your components from the hardest to the softest. So what does this mean is that we want to create the intelligence of your grippers so that they are able to perform tasks with a lower computational force. This is how humans does, is that because we are able to do things very fast, is because at real time we are able to see things with our hands, and we actually coordinate with our brains to perform certain type of decisions on that. And maybe some of others is we are also looking a bit more like a skin. So this is an example, is that by creating different type of particle jamming pressures, we are able to create type of so-called soft robotics or soft skin. Maybe an example, due to the time I'm actually pushing a bit, but this is an example, is that at the soft state, you are able to see that we call it so-called the soft robots are really very soft, yeah. But if you are able just to change the physical topology, this is where it becomes hard. So this is also in terms of the safety also. We want to also have, let's say, to create technologies that the robots can be soft and hard in the same time. Yeah. So we discover this is basically the need of the safety. So these are all very interesting technology, and we also are looking also in terms of mobilities also as well. One example right now is that there's a lot of solutions so that we want it to be very reconfigurable and very modular. So this is not only for the humanoids, but in our factories right now, we are also looking at how do you convert a mechanical, let's say, trolley solutions into a fully autonomous. So we have invest a lot of so-called type of trolleys. And this is actually a very reconfigurable type of solutions where we are able just to attach these solutions into a mechanical trolleys, and is able to move around. Or even in the last one, you can see is that it can reconfigure itself, like we call it like a snake robots, where it's able to understand the whole situations. This is where they are able to reconfigure itself to navigate itself in a very safe way. So the idea was when we have this type of mobilities, this is where we are able to integrate to our robots, where it's able to move around very safely and nicely, let's say, around the factories to perform tasks. So this is my last slide. So the current situations right now for us is that really we are looking at very, we are looking at right now pilot use case. We are also looking at dual arm. And the next few years right now is that we would like to deploy more humanoids to basically understand. And concurrently, we are building up our innovations so that we are able to strengthen our, let's say, our product, and also in terms of strengthen our applications also as well. So with this, then I hope that you all can enjoy my presentations, and feel free to ask me any questions if there's any. All right.
Thank you. A round of applause for Boon.
Yeah.
He'll be downstage. Of course, take some questions if you'd like to see him face to face. Boon, will you be here for a few more minutes? Yes, he will be over here. So catch him before he goes. 2 more presentations before your lunch break, ladies and gentlemen. Allow me to tell you what's happening live right here at the Beyond stage. And also, now, very importantly, that we do have an exciting agenda next in the